Hi class, in this video we want to talk about integer exponents and scientific notation. Okay, so our two objectives obviously are just to talk about how you work with integer exponents and then finally how you deal with scientific notation. Okay, so integer exponents, let's start with that. So the quotient of two exponential expressions with the same base, so remember the base here is what's underneath the exponent, can be simplified by writing each expression in fractured form, divided by the common factors, and then writing the result with the exponents. Note that subtracting the exponents results in the same quotient, so if you, instead of doing all of that first sentence there and factoring it out, if you just subtract the exponents, you get the same thing. So to divide two monomials with the same base, basically all you're doing here is you're subtracting the exponents of the like bases. So here's the rule. For any number a, as long as a is not equal to 0, first if you take a divided by a, obviously they'll cancel out and you're just equal to 1. So this property is true for exponential expressions as well. So for example, as long as x, some variable, is not equal to 0, if you have x to the fourth divided by x to the fourth, that's just equal to 1. So this expression can be simplified using the rule for dividing exponential expressions with the same base. So if you notice here, if I have x to the fourth divided by x to the fourth, the bases are the same. The bases are the x. So what we're going to do is we're going to take the top exponent and subtract away the bottom exponent. So you would have x to the 4 minus 4, which is equal to x raised to the 0 power. So because x to the fourth divided by x to the fourth is equal to the 1, and x to the fourth divided by x to the fourth is equal to x to the 0, the following definition of 0 as an exponent is used. So what we're seeing here is anything raised to the 0 power is going to be equal to 1. So as long as x is not equal to 0 itself, then if you have x raised to the 0 power, that's always equal to 1, no matter what the number is. Okay? Note that the expression 0 raised to the 0 power is not defined in any way. Okay, so let's simplify this. And then in parentheses here, the first one is 12, a to the third power, all raised to the 0 power. So remember, doesn't matter what the expression is. Anything raised to the 0 power is 1. So this whole expression would just be equal to 1. This one right here, let's simplify negative. Note the negative is outside the parentheses, y to the fourth to the 0 power. So the first thing we notice is anything raised to the 0 power is 1. So that's saying y to the fourth is 0. So because the negative sign is outside the parentheses, we negate the final answer, and it's equal to negative 1. All right, so here's the definition of negative exponents next. So if n is a positive integer and x is not equal to 0, we have two rules here. X raised to the negative n, you can make this exponent positive by bringing it down. Okay, so x raised to negative n is equivalent to 1 divided by x to the n. And similarly, if you have 1 divided by x to the negative n, you make this exponent positive by bringing it up. These are equivalent statements here and here. So just remember, you always want to get rid of the negative exponent. So you can bring it down to make it positive or bring it up to make it positive. All right, so let's take each of these examples, simplify the expression by writing it with a positive exponent. So first, x to the negative 10. Well, negative exponent, make it positive by bringing it down as a fraction. So this is just equal to 1 divided by x to the 10th. 1 divided by a to the negative 5th. Obviously, they have a negative exponent in the denominator of a fraction. So make it positive by bringing it up, and you get a to the 5th. All right, let's simplify this one now. 2 to the negative 3. Well, I bring the negative 3, bring it down as a fraction. So this is 1 divided by 2 to the third power. And note when I bring it down, just like the rule says, I make it positive. And then 2 cubed is 2 times 2 times 2, which is 8. So this just simplifies to 1/8. All right, now that the negative exponents have been defined, the rule for dividing exponential expressions can be stated. Okay? So if m and n are integers and x is not equal to 0. So whenever you have the same base, x to the m divided by x to the n, all you're going to all this is equal to is you take the top number and you subtract away the bottom exponent here. That's it. All right, let's simplify each of the following so you can see this in action. X to the third divided by x to the fifth, we'll subtract the top exponent minus the bottom. So this just becomes x to the 3 minus 5. Well, 3 minus 5 is negative 2. Well, negative exponent, make it positive, bring it down. So this is equal to 1 divided by x squared. Y to the 6 divided by y to the negative 2. So it's the top exponent subtract the bottom exponent. So you have to be careful here with the double negatives. So this would be 6 minus, keep this the same, minus 2. Well, negative negative would be a positive, so it would end up being 6 plus 2, which gets me 8. B to the negative 5 divided by b to the negative 1. Take the top exponent, negative 5, subtract the bottom exponent, which is negative 1. Negative negative become positive. So this is minus 5 plus 1, gets me minus 4. And then negative exponent, whoop, make it positive, bring it down. So this becomes 1 divided by b to the 4th. This one here, a lot of negatives going on here. A to the negative 4 divided by a to the negative 7. Well, that would be minus 4 minus minus 7. Negative negative becomes positive, so minus 4 plus 7 just gets you a to the 3rd power here. All right, let's do some other ones. All right, so let's write a to the negative 3 power divided by 3 squared with a positive exponent, then evaluate. Okay, so first off here, 3 like bases, so it's the top exponent minus 3 minus the bottom, so it's minus 3 minus 2. Well, minus 3 minus 2 just gets me 3 to the minus 5 power. Negative exponent, whoop, make it positive, so this becomes 1 divided by 3 to the 5th. And 3 to the 5th power would just be 243, so this simplifies to 1 divided by 243. All right, so the rules for simplifying exponential expression and powers of exponential expressions are true for all integers. So here are all the rules that we have talked about so far in this class for simplifying exponential expressions. Okay, so an exponential expression is in simplest form when it is written with only positive exponents, and this is also important here, when the base only occurs once. Okay, so you can't have something like x squared times x cubed. That's not in simplest form. Okay, so the base only occurs once and no negative exponents. All right, so let's simplify these. Let's work through these. Okay, so the first one here, a to the negative 7 times b cubed. All right, well, first off, I have a negative exponent, so it's not simplified. So to make this positive, I only bring the a down because the negative exponent's only with the a. So the b cubed stays up top, divided by, and this gets written as a to the 7th. All right, let's try this one. X to the minus 4 times y to the 6th divided by x times y squared. All right, so the first thing is the bases occur more than once, so let's clean that up. So the x's here, I'm going to take the top exponent minus 4 and subtract. Since there's no exponent, there's really an invisible 1. So it's minus 4 minus 1 times 6, or excuse me, y to the 6, bottom exponent is 2, 6 minus 2. So let's clean these exponents up. Minus 4 minus 1 is minus 5. 6 minus 2 is 4. Negative exponent, so it's not simplified here. Whoop, bring it down. So leave the y to the 4th up top, divided by x to the 5th. All right, let's try this one here. 6d to the negative 4. This is really important because it's a common mistake. The negative exponent is only attached to the d. Okay, only attached to the d. So the 6 stays up top, and this comes down as d to the 4th power because we changed the negative to a positive when we bring it down. All right, let's move into scientific notation now. All right, so very large or very small numbers are encountered in the fields of science and engineering. For example, the charge of an electron is this right here. 0.000, so many zeros, 160. Okay, these numbers can be written more easily in scientific notation. So in scientific notation, a number is expressed as a product of two factors. One is a number between 1 and 10, and the other is a power of 10. Okay, so to change a number written in decimal form to scientific notation, we're going to write it in the form a times 10 to some power. Okay, so where a is a number between 1 and 10, and n is an integer. Okay, so it'll be a number like -6 or positive 6. Okay, so here's the first thing I want to do. I want to take this really large number here, okay, which is 824,300,000,000, all right, and write it in scientific notation. And then I want to take this number, 0.000000961, and write it in scientific notation. All right, so here's what you do. You take the lead number here. The lead number here is 8. And what you're going to do, all right, is you're going to take and you're going to move the decimal place 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So now I've had this decimal place moved from here to here. Well, I had to move it 10 to the 11th power to get it there. So you take, now I have 8.243 times 10 raised to how many ever times you moved the decimal place. Okay, so now here, I'm going to have to go backwards. I'm going to have to get the decimal place from here to here. So I'm going to go 1, 2, 3, 4, 5, 6, 7 to get to there. So I went from here to here. So this would be 9.61. Now since I moved the decimal place to the right here, I write it as times 10 to the negative 7. So when you move the decimal place to the left, the exponent is positive. When you move it to the right, it's negative. All right, so changing a number written in scientific notation to decimal notation also requires moving the decimal point. So when the exponent of 10 is positive, you move the decimal point to the right the same number of places as the exponent. Like here, if I want to change this 3.45 times 10 to the 9th, I'd move this decimal place 1, 2, 9 times. Same thing here, exponent's 8, I move this decimal 8 places. When the exponent of 10 is negative, you move the decimal place to the left. Okay, all right, this is the same number of places as the absolute value of the exponent. So here it's negative 3, so I'm going to move my decimal place to the left, 1, 2, 3. And then I'll fill in those extra spaces with zeros. Same thing here. I'm going to move it 6 to the left, 1, 2, 3, 4, 5, 6. And you get this number here. Okay, so let's write each of the following in decimal notation, okay? So not scientific notation. So 7.329 times 10 to the 6. So I'm going to move this decimal place. I'll even show you over here. 1, 2, 3, 4, 5, 6. And then all those empty spaces I fill in with zeros. Here, 6.8 times 10 to the negative 10. So if my decimal place was here, I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I fill in those spaces with zeros. All right, so finally, the rules for multiplying and dividing with numbers in scientific notation are the same for calculating with algebraic expressions. So the power of 10 corresponds to the variable, and the number between 1 and 10 corresponds to the coefficient of the variable. Think about it like that. All right, so let's just do these quick problems. So let's multiply the first one and then divide the second one. So I'm going to take 3.10 times 10 to the 5th power times 1.1 times 10 to the negative 8 power. So the first thing I'm going to do is take 3.0, multiply it by 1.1, I get 3.3. And then I'm just going to add the exponents. 5 plus negative 8 gets me negative 3. Same thing over here. 7.2 times 10 to the 13 divided by 2.4 times 10 to the negative 3. First thing you're going to do is you're going to take 7.2 and divide it by 2.4. Got it? And then you're going to go 13 minus 3. So minus 3 becomes plus 3. So 13 plus 3 will get me 10 to the 16th power. All right, class, hope that helped.